Hello and welcome everyone. Thank you for joining us today for this live stream event. My name's Rebecca. I'm the event planner of Microsoft Reactor New York. Before we begin, I'm just going to go over two items with you. Our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and our presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Event guidelines. So this session is being recorded. You will not appear on it. The recording will be available directly after on demand on our Microsoft Reactor YouTube channel. So if you missed anything, if you want to check back on any items that we covered during this session, you can certainly do so at the conclusion of the session. If you have questions, feel free to drop them into the chat. If you have not joined us before on a YouTube stream, just note that you have to create an account to have access there. If you're tuning in from one of the other channels we're streaming to, most likely you have to do the same thing, have an account created to interact. So if you don't have the opportunity to ask a question now while we're live, feel free to reach out to us. We're on Meetup, so you can just find the Microsoft Reactor there and then send one of the hosts a message. So at this time, let's pull up today's session. We're very excited about this one. It's seeming to have a lot of attention from our audience, so I'm pretty excited about it. I think Gwyn is too. Let me pull Gwyn up here. So today's session is Introduction to Bash. It's part of a series of sessions for Linux this month, same time, same place each week. So definitely tune back in after this one. Welcome, Gwyn, again. Welcome back. Oh, you're muted. My fault.
There we go. We're good?
Yep.
We're good there?
Loud and clear, yep.
Hi, Rebecca.
Hey.
Thank you for the introduction, as always.
Sure.
Yeah, we got Bash today. Lots of Linux fans, I'm sure, in the chat. If you're a fan of Linux, drop a little penguin emoji if you have a penguin emoji handy, you know. But yeah, we're like Rebecca mentioned, we're doing a series on sort of Linux on Azure. We're doing Bash today, introduction. We're going to do some Terraform, some infrastructure as code. My good friend Rishabh will be joining me for that session next week. Then we've got containers, Docker. That's the third week. And then last week, we're going to finish stuff up with some Azure Kubernetes service, container
Very
orchestration
exciting.
and things like that. Yeah. I see a lot of people in the chat already. Awesome. Yeah. Please, I encourage all the questions, all the comments, anything you have to say about the session itself. Let me know. I was going to say something else, but I forgot. Yes. If I sound a little funny, I am still a little sick. I've been recovering from, I don't know, the flu or something for the past couple of days. So if I sound a little funny, it's because of that. But anyway, we see a bunch of penguins in there. I love it. Okay, cool. Let me switch.
What is the penguins?
So the penguin is the So Linux is an operating system, like Windows, like Mac, right? And the mascot of Linux is a penguin, and the penguin's name is Tux. Tux the penguin.
Hey.
So when we talk about Linux and we talk about this penguin, we're referring to Tux the penguin, right? Yes, awesome. Lots of penguins. I love it. All right, cool. I should have worn my Tux hat. Goodness, what a mistake, right?
You had one?
Yeah,
I have so many hats. It's amazing.
I have a teal one. All right, next time.
Next time. We've got so many more times. Yeah.
All right.
There's
awesome,
so many
everyone.
penguins coming in.
We're going to switch to my screen now. Let me pull this up here. And we have some links. We have this repo. So these are I like to use GitHub for my notes as I'm sure doing these sessions. And I write them in ways that you can go back and read them. So there's a link to that we're going to add to the chat. And then also on the top right here of this repo that we're going to share with you as well, there's this introduction to the Bash that I highly recommend, because there's sandbox environments and you can run the commands and you learn a bunch of stuff. It takes about an hour to complete. And if you're someone who takes notes and things like that, it might take a little bit longer. But if you're looking for something a little bit more at your pace, this live session that we're going to do today is following a lot of the content on here, but I've put sort of my own flavor onto it. But I highly recommend you go through this and give that a shot, because I love it. I went through it. You learn a lot. spend about an hour or two an afternoon and learning some stuff like that, right? So in the GitHub repo, you'll have links to that. You'll have all the content that we're going over today. And then if you have any questions, you can reach me on Twitter, LinkedIn. I have TikTok, my GitHub, my blog, all that kind of stuff is in there too. As far as for what we're covering today, we've got a little bit of theory. We're going to talk a little bit about what is a command line interface, what is a shell, what is a terminal, what is a shell script, what is bash. Then we're going to dive into some actual commands. We're going to talk about syntax, how we can get help with commands. We're going to talk about wildcards, and then we're going to go into some more fundamental commands. Then we're going to go into some redirection and pipelines. Finally, we're going to practice a little bit. We're going to terminate a process with the kill command. And look into processes with the, what's the process command? PS, I believe. And then we're going to filter some output using the Azure CLI and the Grep command. And then we're going to put together a little simple bash script. I'm going to try to pack everything into an hour. There's a lot to go into. So let's just get started. As always, ask me absolutely anything you have in the chat. I am a massive fan of command lines. I think it's such an underrated skill set. I think if you're looking to get into any tech engineering focused role, especially cloud computing, you're going to do yourself a disservice if you are not comfortable with a command or a command line, right? Command line. So let's dive into this theory it's real quick before we actually get into the commands, right? So what is a command line interface? Oftentimes you'll see this, or no, actually always, you'll see this shortened to CLI. So you hear things like Azure CLI, Docker CLI, and things like that. Before we dive into this, let me bring up this question here. Can we use the Mac Unix shell to follow along? Yeah, this is bash, so you'll be able to do that, right? So anyway, command line interface, CLI. It is a text-based program that allows us to perform actions via commands. And oftentimes sometimes you'll hear like command line, bash, shell, terminal, these terms like mix in. So someone maybe they're talking about like I don't know, a command line when they're really referencing like a terminal. But this is why I'm trying to summarize this the easiest way I can. So command line interface, a text-based program where we can perform actions via commands, right? And that's like stuff like Azure CLI. I can do like Azure -- help. This is how I could work with Azure. There's also like Docker. Did I spell that right? Yeah, correct. Docker, things like that, right? So, and then almost any cloud service that you work with is going to have a CLI. It's basically a way to work with something via these commands, via this thingy here, right? What is a shell? So I think people get a little confused between like CLI and shell the most. And shell is a program that allows us to run commands. And if those commands are built into the shell themselves, you can run those, or it's a way to actually run your CLIs, right? So I'm using a bash shell, right? And I can use this to execute my Azure commands, my Docker commands, my Kubernetes commands, whatever CLI it is that I'm working with, right? When it comes to Unix systems, so Linux, Mac OS, things like that, right? There are many different Unix shells, but they all derive features from the Bourne shell, which is it's SH for short, right? And that's what we're going to be working with today, right? What is a terminal? Okay, so a terminal oftentimes, so you'll say terminal or you'll say console. So terminal is the program, the sort of thing that we use to access a shell, to run commands. So the GUI part. So this program, for example, Windows terminal that I have open here on the left side, this is a terminal. Sometimes there's also console, which I think consoles is more of like the physical, like there's actually a physical thing that I can touch to access these commands, right? But these days it's more of like a UI. So Windows terminal, there's Quake that I've used a lot on like Ubuntu, Pop! OS. iTerm 2, I think, is one of the most popular ones for Mac, things like that, right? And let's talk about a shell script. Okay, scripting. Everyone knows scripting is a very, very important skill set. And what exactly is a shell script? So essentially, it's a text file that contains a sequence of shell commands. It will write our commands in there, and we'll write one towards the end, and we can execute them. We'll execute the script itself instead of having to do the individual commands because the commands are inside of the text file, right? Let me take a pause here to just grab all your questions because I don't want to necessarily leave them all for the end here. Fun fact: Linux, in the grand tradition of open source recursive acronyms, Linux is not Unix. Very neat. Very fun fact there. I see some more penguins in there. Very, very cool. I'm loving it. Let's see here. Is the shell same as saying operating system? No, a shell is a way of working with an operating system, but it is an operating system itself. Like you can interact with the OS via commands. OS is short for operating system, but it's not an operating system itself, right? I just picked up the Linux Basic for Hackers GPS recommendation. I love that book. I learned a lot. Very fun book. You know, I'm sure you can Google it and find it. But yeah, okay, cool. Last thing here. What is Bash? So, like I mentioned, the Bourne shell is sort of like the OG shell that was available for Unix systems, that is available for Unix systems. But, you know, Linux has many flavors of Linux and many flavors of shells. And there's one called Bash. Bash stands for Bourne Again shell. So, you know, B, A, and then SH shell. So that's where you get Bash from. And it's become sort of the de facto, like the standard for working with Linux machines, Linux service. And when you think about cloud computing, servers, you know, Linux servers like network together, that's essentially what cloud computing is, right? Yes, there's all these serverless services and serverless things there, but under the hood, everything is pretty much Linux servers, right? So when you think of Bash, you can almost consider it sort of like this universal language, because you can expect it to be, at this point where we're in 2022, you can expect it to be available for you on a Linux server without you having to install something. So, you know, you don't have to install Python, you don't have to install .NET or anything like that, right? It's like on there, and if you've got some skills, you can like spin up a server and not have to do anything because you can already like interact with it via a command, right? Or a command line, right? Okay, cool. Let's dive into some fundamentals. Let's see. We got any questions that I need to tap into before it? No. All right. Cool. All right. So yeah, I'm using Windows Terminal. I'm actually using WSL, and I have Ubuntu set up. You see, I have PowerShell here. I have the Azure Cloud Shell. I have Git Bash, Ubuntu. You can also access a shell if you go to like shell.azure.com, and then this is like a cloud shell. And you have the option to use PowerShell or Bash. We're obviously going to be using Bash here. I'm going to stick with the Windows Terminal one just because I've created some files there already that we're going to be working with. But if you don't necessarily want to install something locally, and you can use your Azure account to access this. Pretty neat, right? Okay, cool. So let's run through the full syntax of a Bash command, right? So let's list out. I have an example here. So this ls here. -A, and I'll explain it all. We'll piece it apart. So the first part here is, we have command, we have options, and then we have arguments. And sometimes you can run commands just on their own. Sometimes there's a required argument. Sometimes, you need to provide the command something for it to do. It can't just work on its own. Sometimes it doesn't need anything. And you also have this concept of options, which are also referred as, flags. And whenever you have like a dash, a letter or something like that, or dash a word, that's considered an option or a flag. And they modify how commands work. So in this case, I have ls-a and then /etc directory. So the ls is the command itself. This stands for essentially listing the contents of the argument that we provide here. And by default, it'll just list the contents of the current directory that you're in. And then we have the -a, which is an option. Which includes hidden files. In Linux, anything that starts with a dot, whether that be a file or directory, is considered hidden. So when you do a normal ls without the -a here, and I'll show you all this, I'm just trying to explain it beforehand, right? You're going to get the hidden files as well, right? So if we do ls-a here, we can see here we get a bunch of stuff that's in the etc directory. So essentially we're telling, all right, Linux, can you list everything that is in this directory here, including the hidden files? And you see we have some hidden files here. And if I remove the -a, where we go here, we don't get the ones that start with the dots, right? Where do we go? Here, see? So we don't get those ones. Okay, so essentially that's how you have commands, you have your arguments, and then you have options that you can provide. And you can combine options or flags, things like that, with, just instead of doing it /l-a/etc like this. And the -l stands for, it's like a formatting thing. I don't exactly know. Maybe it stands for like -long or something like that. So instead of doing them individually, we can just do we can do it like this, la/etc, right? Things like that. Okay. And when it comes to like sort of keeping things concise, this is where like Bash enthusiasts or people who are really great at Bash tend to like flex their skills, because there are some really impressive combinations of commands out there that you can just spend your sort of your career working with Bash, and like 20 years in, you'll discover like, oh, I had no idea that you could combine things like that, right? It's like an art to an extent, like working with commands and command line and terminal and things like that, right? Okay, cool. So yeah, we know we can combine it, and then we mentioned here combined and then the long form, right? Now keep in mind, you're gonna want to use the long form when you're putting things in scripts because it's easier to read. But if you're doing just one-off commands, it's easier to use something combined, a little bit more concise, right? But now you might be asking, Quen, there's all these commands, there's all these arguments, and I could probably like learn like, the list to change directory, print working directory, man command, all these kinds of things, the ones that you use the most. But, all these maybe have like several options and arguments to them. How am I supposed to know what to do? And my friend, that is a fantastic question. Because, oh, come on, I don't want to install these drivers, sorry. Because understanding how to read documentation and how to find help for the commands that you are working with is very important. Luckily, Linux has a built-in documentation or manual, for lack of a better word, that's called man for short, right? So here we have sort of man, and then I provided a command here. Man make, oh, can we go large screen? I don't know why it went small. 1 second. There we go. Thank you. So how do we access this? Well, we provide the man command, and as an argument, we're providing another command. Let's say man, I don't know, make dir, which is the make directory command. And you see we get the name of the command. Make dir stands for make directories. A synopsis, which is like a one-liner of how to use it. Make dir, options, and then directory. And then description, it tells create the directory or directories if they do not already exist. And then it tells us some arguments, some options, and things like that, right? Fantastic. So we know how to access command, and there's a lot in here, right? You can read a bunch about this. Some commands will have more, some will have less, and things like that, right? So that's how you access help. Now, become very familiar. If you are trying to figure out, how to work with a command, you don't remember an argument, things like that, I highly recommend that your first go-to would be the man option, the manual page, and then go Google or do whatever searches you need to do, because this documentation is available to you in Bash, right? Available in anywhere you're working that has Bash available. Another neat option for help is the -- help syntax here. I can probably make this a little bigger here. This syntax here. The cool thing about using this is it's a little bit more concise. So if I do make dir -- help, you see, this is it's a lot shorter. It almost gives you sort of like a summary. Sometimes the information that you're looking for might not be here, right? But essentially, its goal is to have sort of like, the most like important information extracted from man. Now, what I really like about using this -- help option is when you're working with other CLIs, it's sort of a standard that you can use -- help to help you figure these commands out in other CLIs when you're not working necessarily with Bash commands. For example, if I'm new to Azure and I want to use the Azure CLI, which is AZ, you'll have to install it, of course, but then you can use AZ. And I'm like, all right, I know I can access the Azure CLI using AZ, but like I don't know anything else, right? So I can provide -- help, and then we get a list of help things, right? It's telling us here. We got here, all right, we can work with OpenShift, we can use app config, we can work with groups, we can work with, a bunch of things in this list too. All right, so say I find the command that I want to work with. I want to work with AZ account, but I don't know anything else. Well, I can continue to provide the -- help there, and it will continue to give me the documentation that is specific to that chain of commands. So this isn't the documentation to AZ CLI. This is the documentation to AZ account, specific to that. And now, great, I see AZ, I don't know what I want to do, like AZ account, like, oh, I see list here. So if I do AZ account list, all right, I have a better idea what I want to do, but I still don't know exactly. I can provide help once more, and it's, again, documentation specific to that command, right? And this is great. And this is the same for like if I wanted to work with a Docker CLI -- help, and then I get documentation relevant to that, right? And this is all built into the CLIs. Like the documentation itself is up to the, I guess projects or companies that create the CLIs. Like they have to keep up to date and, make sure they provide great documentation access via the help. And the cool thing about, like, for example, the Azure one, Azure, I don't know, VM -- help is like sometimes they'll give you examples as well. Like you can find, it says here, for more specific examples, use AZVM. Like if I did AZVM create -- help, I'm pretty sure it's going to give me some examples of like create multiple VMs with this command, create a VM in an availability zone with this command, and things like that. Which when you're getting started and you don't know how to put these things together, you can just copy and kind of work with it, right? So that's the good part about that. Let me take a look. I want to answer questions so I don't get too behind on them. And I see a bunch in here. I write Node.js apps. Are the scripts and packages .json file bash commands? I'm not familiar with the scripts in package.json for Node apps. So I can't say yes or no. I'm not a Node developer. But I wouldn't be surprised. If there are any Node devs in the chat, please, feel free to chime in and let me know. Let me take a look at that. Yes, we are recording this session. So this will be available for everyone to reference later on. In your opinion, which is the most powerful shell? Oh, I'm just so powerful. For me, it's like, it's like the one that the most. And for me, it's Bash. I'm going to say Bash, but it could be something else. But yeah, and I guess like they're all very, they all share similar features, right? Okay, so powerful is the one that you're most efficient with. That's what I'm going to say, right? Okay, so all right, we know how to get help, things like that. We know how to get help with other CLIs and stuff like that. Let's talk a little bit about wildcards, sometimes called meta characters. Though I don't think I've ever heard meta characters. I've always usually heard wildcards. But anyway, wildcards are symbols that represent one or more characters in bash commands, right? So for example, when you're providing a command, or sometimes you're looking for something or you want to work with something that you're not 100% sure with the name of it or the extension or something like that, right? And it would be impossible for you to even know where to start because you don't know the full name. That's where wildcards come into place. So for example, if we use the asterisk, it represents 0 or a sequence of characters, 0 or more essentially characters when you utilize it. So for example, I have here a bunch of files. I've got this one.png, I got an output.txt, I got a nano.txt text file, I got pick one, that's a PNG, a pick three, that's a capital JPG. I don't know what the difference is there. I got a JPEG, there's another extension there too, right? So I have a bunch of files in here too. What if I only wanted to list the files that ended in PNG? I don't care what the names actually are. I'm just looking for the ones that end in .png. Keep in mind that extensions in Linux is a little different. So unlike other operating systems, Linux doesn't really care for the extensions of files. It's not that they don't matter. It's like Linux sort of assumes the extension via the contents of the file instead of actually relying on the extension itself. So you can name a PNG file like anything else. It still would know that it's a PNG. But for this example, it's like really helpful to like play around with wildcards when we talk about extensions. So that's why I'm using it. Okay. Alrighty. So yes, we're talking about the asterisk wildcard here. So if I wanted to find the PNG files, I could simply do ls *.png, and it would show me only the ones that end in PNG. Let me do a -l there. -l. There we go. Only the ones that ended .png. Now, sometimes I see people sort of get confused because this asterisk is, though it's just one symbol, you might think that, oh, it just means like one place, like one letter, like one character. But no, remember, it's 0 or more characters, right? So that's why it's giving me, this one has 1 before the .png, this one has 4 letters, and then this one has a whole bunch more. And they still sort of meet that requirement, right? Well, what if we were looking for files that only represent a single, or like a character, like a single character, right? Then for that, we could use a question mark. So let's list out these files again and see what we're looking for. So say we're only looking for files that are end in PNG and that have just 1 digit. You know what? We'll probably have to create another one. So if I do pick 1, 2, 3, .png. I'm using the touch command. I don't know if we have the touch command in the list of commands I'm going to go over. Touch is essentially made to modify a creation date of a file, but it's often used as well to like create a new file. Just a little fun fact there. Okay, so let's do ls again. This long here, and now we have pick 1 PNG, pick 1, 2, 3, pick 3, pick, things like that, right? But say I only wanted to find files that have pick 1 digit or 1 character and then .png. Well, I could do here ls and then the character, the question mark here. Where am I? Right here. This one here. 1 pick, actually 1 .png. Correct. Here we go. You see, we're only getting this single one here because only this one fits what we're looking for, right? And so just understand, like, the question mark is the 1 character, single character, not more, not 0. 1 is specific there too. We can also use brackets to denote a group of characters. So say we're looking for all the ones that have .j or .p, right? And then for that we could use ls and then asterisk, because it can have any sequence. We don't know what the name is. Then it's going to have a dot, and then it's going to either be a j or a p, and then it's going to have more letters after that. And we have a bunch here. Let's do an ls.l here. Fantastic. We have all of these here too. But do keep in mind that, for example, if we do ls.l here, now we have this capital one here. We got these txt's in here. But you might ask, like, all right, we're looking for j and p, but this capital one, j, didn't come in there. And you are right, my friend. Bash commands are case sensitive. So in that case, if you're looking for it to include all of those, we would have to do a capital J as well here, and then a lower capital P there if we wanted to, and then we would get the ones with the capital, right? So keep in mind, case sensitive, right? As most things are when you're working with scripting, programming, things like that, right? Oh, and we could also represent a range with brackets. We would have to use the dash for that. So if I did ls, like, just list everything A through Z, we'd have everything there. And if we wanted to just the ones that have capital A through Z, oh, hold on here. We'd probably have to do this a little different here. So it starts with anything, and then it has an extension that's a capital letter. You could probably do it like that, and then text after that. And then we'd have the capital one too, right? So ranges can be supplied via a bracket and then these dash here, okay? Okay, cool. So those are wildcards. We're going to use that a little bit more when we use grep, filtering, and things like that. Let me grab some questions before I go into here. Man, make dear works, but no luck with make dear help. That is a good call out. Some of them will not. So some commands won't have man. Some commands won't have -- help. This is great. So for example, the cd command is here. So if you do man cd, you're not going to find cd is change directory. We'll cover this in a little bit. No manual, and you see here it says no manual entry for cd. That's because you'll have to do man built in, because cd it's like an exception to an extent. It's a built-in command. It's not necessarily like a bash command. It's more specific to like your environment per se. But if we do man built-ins and then we like search for cd, if you do / in man, you can search. And then we see we have the cd command here, and then it's just, you'll have to search for it and find more information of it. But yes, that is true. Sometimes there isn't a man entry. Sometimes there's a -- help. So you'd have to like go back and forth in that. But for the majority of them, it is available. Okay. We're asking, can we read? I can't read the URL for your document here. We have the GitHub repo in somewhere. So can we share that once more? And yeah, this is just a GitHub repo. This is on that I use sort of like my presenter notes, right? But I write them in ways that everyone can go back and reference them later. So we'll drop that link once more. Okay, cool. Where were we at? All right, so we've been playing around with the ls. We can list commands, and like I mentioned, some of the popular options are -a to include hidden files, and directories, and -l to include more info about each file, which we get ls.l here. We get permissions here. We get who's the owner, the group, and things like that. Creation date, the file name, and that kind of stuff, right? Then we have the pwd Pwd command, which is print working directory. This command will output where we're at right now, right? I mean, my terminal tells us right here, but in case I needed it to save to a variable or something like that, I could use pwd, which stands for print working directory. Cat. Cat stands for concatenate. Let me make this. We're on this one here at the moment, right? I could probably make this a little. Where are we here? Here we go. Cat. Cat stands for concatenate file or files to standard output. We're going to talk about standard input, standard output, standard error in a little bit. But it's a fancy way of saying display the contents of a file to the screen. So I don't know, let's make a file. Let's use Nano. Shout out to all any Nano fams. Are we Nano versus Vim versus VI kind of people here or not? I try to use whatever I remember at the current moment, right? So we're gonna create a file called hello nano.txt, unless I already have one. I don't remember if I have one or not. We're gonna say hello nano fans, right? And then we're gonna just save that there. Fantastic. And then if I do cat, which is the concatenate, and then provide the file for the name of the file that we just created, we'll see that it prints out the contents of the file. So that's what we would use cat for. We went over man already. We went over cd, which is, actually, I don't think we did cd. Cd will change directories. So if I want, and I mentioned, look, I wrote it here too. I did not remember that I did. If we needed help with the cd command, you have to search for it in the built-ins manual page. Okay. If we wanted to move up, we'll go this way, right? And it looks like I went a folder back. So remember, when we think of like a file system, it's like a tree, right? So if we wanted to move up, we're like essentially moving out of the folder, right? And then if we wanted to go home, we could use the tilde here. I don't want to go home. I want to go back into this file, this folder actually, bash demo files here, right? So that's how the cd is, how you move around, right? Right. Make dir. Make dir is for us to create a directory, create a folder, right? So I can do make dir, I don't know, let's say dir1. And then if I ls, you can see I have this dir1 here. I can also do make dir-p, which is one of the popular arguments to pass or options to pass with make dir, and that'll allow us to create like subdirectories. So if I do dir2/subdir1, now I do ls, you can see ls-l, I think this one will show. We'll say dir2 has this here too. So if I go ls dir2, it might be able to show us there, and we're printing the contents of dir2, which is a subdirectory too. So pretty handy to know when you need to create subdirectories when you're working with the make dir command. All right, where are we at? Okay, remove dir. Remove dir is for us to delete empty directories, delete empty folders. So since that dir1, we didn't create anything in it, we should be able to just do remove dir1. Fantastic. But if I try to do the same with dir, what was the other one? I think we called it dir2. We call it dir2? Goodness, where is it? Yeah, dir2. So if I do remove dir2, we're going to get an error. It's telling us failed to remove dir2, directory not empty. And that's because we have another folder. Even though the folder has nothing in it, it's still not considered empty, right? So that is where our remove command comes in handy, which is just the rm here. All right. So let me actually see what we got here. So I'm going to actually delete a bunch of this stuff. So if I do, for example, rm, and then I say 1.png, and we see we got rid of that too, right? And I actually want to remove anything that starts with pick and then ends with literally anything else, right? And then I removed a bunch there. So you see how the usage of like wildcards, I just used that asterisk and I got rid of a bunch of files that I didn't want. And I also don't want any of these text files, so I could probably do remove anything that ends with .txt, and then you see the only thing I have left is this directory, right? So yeah, getting comfortable using wildcards and commands, it's going to make you much more efficient, a lot quicker also when you're working with commands, right? So anyway, I was saying, how do we remove this directory that has things in it? Well, you should make it a habit to use rm-i, which means it's going to ask us to be prompted every time. It's going to prompt us every time we need to remove something. And then we can use R, which is recursively. So we can combine these two and we do RI. Recursively means it's going to like go from the subdirectory back up, right? Which matters because we have a subdirectory here too. And then we're going to provide the name of the directory. Oh, how did we call this? Oh, it's dir2. Oh, here we go, dir2. And here it says descend into directory 2. I'm going to hit yes. Remove directory dir 2 sub dir 1. And I'm going to hit yes. And then finally it's saying remove directory 2. Yes. And this is just, cover our behinds to make sure we don't delete something that we don't need to delete. All right. Clear. Now, what do we got here? All right. Finally. Oh, copy files. Okay. So for this, pretty simple. It's like kind of like right click copy, but let's make a couple of files here. We'll make I don't know here, notes1.txt. And then we'll make a directory. We'll call this directory 1. And then if I copy notes, copy notes1.txt to dir 1, like that. And then I do ls dir 1. You can see that notes has been copied from its existing place. So it's still here. It's still in this bash demo files directory, but we've also copied it over to the dir 1 directory, right? So very handy. There's also move. So if I did, hold on, let's go into dir 1 and then remove notes, right? And then we'll go back. We'll clear this. And then if I did move notes, notes, there we go, to dir 1, you see we no longer have notes there. So we can copy, we can move depending on what you want to do, right? And then we can move all that jazz. Alrighty, we got PS, which is used to get a snapshot of all currently running processes. We're going to do an exercise with a little bit more of this in a little bit, right? So essentially, if I put PS, it's just going to show me the processes that are running at the moment. We have the Z shell moving in here, and then we got PS as well too. All right, fantastic. Sudo. So Sudo stands for super user do, and when you're probably going to hear this term word super user, it means the root user, right? So the user that has the most privilege on the system. And there are oftentimes commands that you need to run with sudo. So for example, if you wanted to like update your distro, your machine, you would use apt-get update, but you can see I'm getting here permission denied. But if I do sudo apt-get update, then I should be able to provide the password to the account and then go ahead and update my machine. And there are a bunch of reasons why you would want to use sudo instead of logging into root. For example, I've got a few specified here. So if you run stuff as root, you're not going to have a record of people who are running the accounts that are running these commands in the first place. You also don't have access to your normal shell environment, right? And most distros are going to use this sudo package, and it allows us to run commands as root, though we're still ourselves, right? So I'm still made by GPS, but I'm running as root. So keep that in mind too. And we would preface the command with sudo, and that's how we would do stay super user do this command, right? Essentially, that's what it's telling me. All right, redirection. We got about 20 minutes or so. Hopefully we get through the rest. I'm gonna try to like go through this one pretty quick, and then we can get to the fun stuff, grep and shell scripting and stuff like that. But let's see. Let me see what people are saying us. Nano's just easy, but teach its own. Okay, cool. Nano, we got Notepad, we got Nano, but fall back to VI, VI Vim. Can we say cat command is like a run command? Cat is more of like a print command, similar to that, right? Good stuff. Remove -r versus remove -r still always trips me up. Be very careful there as well. Do you have a link to this? Yes, we have the links. We're sharing them in that means in the chat. Recursively means we're like sort of going into the subdirectories and then moving, like we're like looping through that, and then we'll go through the directory above it and then above like that, right? Recursively. Yes, here we go. Perfect. Dasin means the command will go below the current directory. Exactly. There we go. Perfect. Right. So we'll go into the folder, figure all the subdirectories out, and then move our way up into whatever the command it is that we provided. Right. Working in Bash while watching talk on Bash. So much Bash. You can't get enough Bash, people. We love it, right? All right, cool. Let's get back into this. So redirection now. This is where you can really start understanding the power of a command line. Embrace the power of a pipeline. And pipelines are essentially put together by commands and using redirection, right? Don't worry, we'll get into this, right? So input output direction allows us to redirect input and output of commands to and from places, files, as well as connect multiple commands together into a pipeline. So as a summary, we have to use this symbol here for redirecting input to a source other than the keyboard. This symbol here, the greater than, for redirecting output to destination other than the screen. If we wanted to append, we would have to use 2 of these here. So instead of overriding, which is the default when you're redirecting standard output, you can append. And then we use the pipe symbol or character for piping output from one command to the input of another, okay? This is a little bit of summary, but we'll do some examples here. So redirecting standard output. Standard output, also known as STOut, this right here, is the program's result. So what you see sort of printed out on the screen. So when I do like ls here, this what's here, this is what's printed out, is known as standard output. To redirect this content, so the content of like what gets printed, what gets shown to a file instead of like default to the screen, we can use the greater than symbol. This might have a better name for it. I know it is greater than, it might have a different name, but it's also redirection operator, the standard output redirection operator, and the name of the file, right? So for example, if we wanted to say get the contents that is in the, here I've got the /user/bin, which is sort of a directory where like process like scripts and binaries and stuff get saved to a file called ls-output.txt, then we could do this command. So we'll do ls-l, so we'll get the long form of the content, from user bin, and go ahead and redirect that output. Don't send it to the screen, send it to this file called ls-output.txt. If this file doesn't exist, it'll create it for us. If it does exist, it's going to get overwritten, right? So let's hit that. And you see nothing printed out to the screen. But if I use our good old cat command here, and I provide in the file name, you're going to see that it is now the contents of this file. Clear. Put it up too. Okay, cool. And if you wanted to append, you would use this one here instead of the other one, right? How do we redirect standard error? So standard error messages, like for example, when I got that permission denied message, that would be like standard error. It's also known as std error. We have to use its file descriptor. So in order to do this, the shell references standard out, stout, stdin, and stderr internally with its file descriptors. So 0, 1, and 2. Right? So 0, respectively. 0 would be stout, 1 would be stin, and then 2 would be stderr. Right? So we can redirect the standard error to some sort of file or something like that with the this notation here. Right? So for example, if I had some sort of error, we could just do we'll just do the command that's in here, ls-l/bin/user, and then we do 2 because it's standard error, ls-error.txt, and then since then we'll do cat ls-error here, and then we see cannot access this location. This is the contents of that because it doesn't exist, right? So purposely we did something that was incorrect, right? But you see that when we did that, we didn't get the output to screen because it was redirected to this file, right? Clear. All right, I'm trying to skim through this. Again, these links will be available for you to reference later. But yeah, if you wanted to sort of redirect standard output and standard error to one file, you could use, I think there's 2 ways to do this. Yeah. So in older systems, you would have to use the redirection, right? And then at the end, you would add 2 and redirect to 1 as well. So remember, those are the file descriptors. But in the newer ones, you can just use this ampersand and it'll redirect it to. Just keep in mind that in order, the order of the redirections matter. Standard error must always occur after redirecting standard output. Okay, cool. And finally, standard input. So standard input typically with commands will be a keyboard. In order to grab the content from somewhere else, if you're not using a keyboard, you could send it I think I have, hold on, let me see. So if I did, for example, cat and then redirect the standard input from, let's do ls-error. You see it prints it out, right? instead of doing cat file, we just redirected the inputs. Like, all right, your input is the file, not the keyboard itself, right? So that's how you would do that one there too. Okay, let's talk about pipelines. So pipelines is sort of essentially us chaining commands, right? So we're grabbing one command and sending its output to another command. So the input of the other command essentially becomes the output of the first one. And this is where, you know, bash scripting, bash commands becomes somewhat of an art, like I mentioned earlier, because the pipelines out there, it's like, it's for every pipeline out there that you are familiar with, I'm pretty sure someone else has found like a more concise or perhaps a more efficient way of doing it. Yeah, and it's really, really interesting to like just look at examples. Like there's a bunch of like subreddits on like command lines and stuff like that, and there's a bunch of like Stack Overflow threads on this kind of stuff. But it's pretty neat. So essentially what we're doing is, you know, we're using this pipe operator, for example, this one here, and we're building sort of like chains, right? So we can use the PS command, which is to view a snapshot of the processes. We'll do -f, and then we'll use a command there, like a pipe, and then we'll do grep, and then daemon. What's going on here is, all right, we're grabbing the output of this PS command, and then we're not showing everything because grep is going to grab that input and then just show us anything that matches daemon. We're going to dive into grep in a little bit later than after this one. Okay. Yeah, so pipelines, you're just kind of chaining things. And for example, there's this longer one here. If we cat, clear. We cat ls dash error, you know, we'll do this other one, ls. What's the other one called? ls output here. We'll do ls output, and then we'll send it to fmt, which will format it for us, and then we'll send it to, you see, we'll have like sort of this, I think it formats it in paragraphs. And then if we do one more here, we'll do it in PR. We'll see, we have it set. I think this one actually does it in paragraphs. Let me see. Or like principal, something like that. I can't remember exactly what it does, but it's like a formatting thing. And then if I do LPR, I think this is like to make it to printable, something like so you can actually print it to like paper. Or actually, I guess I don't have it. But anyway, yeah, essentially you're like grabbing output one, filtering it, and we'll see this a little bit more with like a more like common use case when we use the Azure CLI. All right, terminating a misbehaving process. All right, so we're gonna talk a little bit about sort of how we can use the PS command. So when you're working with Linux administration, Linux servers, you're probably going to trying to figure out like, oh, like, is there like some sort of service, some sort of process that's going wrong? And you kind of want to be able to figure it out. So we're going to sort of mimic like how to terminate a misbehaving process, right? So what we're going to do is we're going to create a file, like a Python script. It's called bad.py, right? And we're going to use vi in this one here. So we'll do vi bad.py. Then here we're going to have to insert this. I could probably just copy this here. Copy. How do I insert in VI? Is it just I, right? Yeah, I think so, right? And then what is it? To escape? Is it just like WQ? I think that's it, right? Yeah, I think that's it. Sorry. I think that's like one of the tech Twitter jokes is like, I don't know how to like get out of Vim or VI and things like that, right? Okay, cool. So we've created a file, and it ends in .py, so it's a Python thing. And we've added this sort of process that is meant to cause some craziness to in our terminal, right? So we can start this by just saying bash python 3 bad.py py, and then we're going to use the ampersand. This one here. But what's going on here? Why can't we do this? Bash. Oh no, should just be Python 3. We don't need bash, right? There we go. Okay, cool. So this ampersand means run the process in the back. So like if I didn't use the ampersand there, it would have sort of like taken up the terminal, and then I couldn't like type any more commands, but now we're running it in the background, right? Okay, cool. Now, if we do a little PS here, we can see we have this process running. And when I ran this before, we didn't have it, right? We see this process running in here too. But if we do ps.ef, we get more sort of information, like more process, not just one specific to me or to my like shell. It's like sort of all the processes running too. Now, if we did ps-ef, and then we're going to do a pipe there and then grep Python, we're going to get just the information of the Python thing, and then we can see that well, I don't know if y'all can hear the fans of my computer sort of just kicked on. And then we can see that it's sort of taking up a lot of CPU time. It's kind of hard to see here because we're like really zoomed in. But yeah, so essentially it's telling us like, hey, this process is like going crazy, right? So let's clear this. And so how do we end this, right? There's this command called kill. It's just called that. It might be a little aggressive or something like that, but who knows? If we do kill-l, we can see all of the signals that we can send to a process to sort of end it or restart it. And I don't know each one of these signals, but I think the default is sig h up or hup. I don't know how to pronounce it exactly. If we wanted to restart it, right? But in this case, we want the process to just end without sort of restarting, right? So we can just use kill-9 and then the process ID. Oh, I didn't copy the process ID. Let's do ps ef grep python. And then the process ID looks like it is, what is the price? 99. Hold on. I might need to do this a little smaller here so I can tell what the process ID is. Grep python. I think it's 99. Let's try it. Kill-9, and then it's saying it's 99. Nope, it's not 99. I can't tell which one it is here. Let's just do PSP. Oh no, here it is. It's 790. Oh, it's this one here. My bad. I was looking at the wrong column. All right, so kill-9, which is the signal that we want to send the kill command, and then we provide the process ID, which is 7907. There we go. So now we do PS. We see we no longer have Python, and that's how we end a misbehaving command. All right, our process. Right. Okay. Let's talk a little bit about grep and filtering output, and then I might be able to get to the rest of these exercises that I have here. But yes, anyway, grep. Grep is very cool. Grep is very, very capable. Grep, alongside the awk or awk command, are probably two of your best friends when it comes to using Bash. Grep, I think, stands for like global regular expression something. I don't know. Maybe man will tell us. Grep stands for name. Does it not tell us? Maybe I wrote. Okay, global regular expression print. Okay, I was close. Let's say that too. So say, for example, we wanted to list the VM sizes we have available with Azure. So I can do Azure, so AZ, which is the AZ CLI prefix, AZ VM list -- sizes. And then I want to look them up for East US 2, which is where I'm based. And then let's output that into a table. So -O, which is the option to output it in the table. This is probably going to get us a lot of information, right? Okay, cool. So I'm going to clear this, and there's a lot in here. I'm like, all right, maybe I don't want all of these. Like, I just want to look for the ones that are DC something, right? So I can do, again, we can just use the arrow up to sort of recall our history, and then we can use grep, right? I've actually added this in here, more to the side, and I'm, all right, so I just want DS, and remember, here's where we're going to use wildcards. And then we're expecting some kind of character, and then an underscore, and then a V2, and then it ends with that too. Oh, hold on. It looks like we didn't find anything that starts with this. How come? I did this backwards. I believe so. Right? No, that's fine. Let's look at the output again. AZVM. So we have DC. We've got DC2S, we've got DC V2, we've got DC, hold on, we got more up here, I believe so. Oh, there's so much here. DS, standard, underscore, DS. I thought we had a DS V2. I might have like put it in wrong here. Let's see, everyone. We've got some, it should match that. I'm not sure. I'm pretty sure I tried this before. DS underscore V. All right, well, let's figure it out live. So we know we want to do, and then grep table, and then we want to grep only the ones that match, that have some sort of DS. And let's see what happens when we just do grep ds. Okay, cool. Let's pair this with the awk, and then we'll just print out the like specific column. awk can be a session completely on its own. Here we go, print, and then we only want to print the third column here, and then we'll type this into the grep command here. And then you'll see, well, oops, got to close this right here. Boom, there we go. And then we see we're only going to get this column here too. Okay, so we have a bunch more here. Say we want just a ds with some sort of command, some sort of digit, yes, digit, that's what I meant. But only one, and then we do underscore. What happens there? No match is found for that one. Interesting. There, like that. No match is found for ds. What if we wanted only the v2 ones? I guess we could probably do something like anything and then like go dash v2, something like that. No match is found for that either. What is the issue here? Is it because I need to do like encapsulate this like this? Let me take a look here. Underscore v2 like that. Ah, I figured it out. I forgot to encapsulate them in single quotes, because I'm assuming it like didn't recognize this as a regex in this thing. But it's interesting because I feel like I've done this in the Cloud Shell and it did work. But anyway, all right. So now you can see our output for this list images is only the ones that are ds something, ds something, but v2, right? And that's sort of how you use grep for filtering. We're gonna have more examples down here, right? But it's I kind of want to get into bash scripting, but I guess I have more examples here of grep. Take a look at those, and then I did like a bunch here that you can sort of copy and kind of work with, just because I want to like wrap up. I want to be respectful of people's time. We have an hour left. All right, so let's just do a little introduction into bash scripting and create a bash file, right? So let's create a file. We're going to use Vim for this. I guess we can use Nano because we used Vim before. We're going to create a file called create files .sh. Fantastic. And then I'm just going to copy this here because it's a little easier. And then this first thing is called a shebang, right? We're essentially just telling the shell, hey, which script are we, like where are we, what are we using to execute this? And essentially we're just telling it, hey, we're using bash, right? And then we have a little comment here that describes what the script is doing. It says say hello and create some files. Echo means to echo the message that's within these single quotes. And then in this case, I'm just saying creating files for you. And then we've got a loop. If anyone's familiar with programming, looping is just doing something until some sort of something ends, right? So for f, it's just like a variable. And remember, we can use ranges. So from A through Z, and then from 0 through 5, we're going to echo hello to a file. Done. So essentially, we're going to create a bunch of files, right? And then here, what we're going to do now is exit, and then we're going to save this here and then clear this out. And now what I'm going to do is just cat that file. What was it called again? Create file, something like that, right? Just to make sure we saved it correctly. Cool. Now, we can't execute this. So if I try to do, what is this called again? Create files like that. It'll create files for us, but we can't execute it without, like, if we wanted to do just create underscore files. Actually, it might. No, you see, it says command not found, create files. And why is this? It is because it doesn't exist in our path. So how does bash know, like, I can write like ls, right? And I can do like a bunch of different commands. And if you install like packages and stuff like that, they might have commands. Like, how does bash know where to look for these commands, right? So there's this thing called a path. And it's spelled like this, uppercase, all letters uppercase. And these are all the directories where bash knows to go and look for things that I can execute. So you can see up here, we have like user local sbin, user local bin, user bin. When you like have scripts that you like put together and you want to be able to run them, I think a good one is user/local, user/local/bin to save this. So we can just move this file, which is create. Well, you know what? Let's actually copy it. Create files to /user/local/bin. You could also add a directory to your path, but for this case, we're just going to move it because it's better to like move it and we're in like a directory that's expecting your scripts to, instead of like just adding like a random directory to it, right? Cannot create regular file. We're probably gonna have to use sudo here. We're gonna do sudo, and then what we're gonna do is provide the password. Alrighty, so we've moved it. If I do cat, hold on, clear. If I do create files now, create underscore, hold on. Let me remove all these files first. Remove all files that just end in txt. Remove all files that end in txt like that. All right, I have no files, right? I'm just going to remove this dear one as well. Remove dear one ls. Fantastic. All right, so you see I have no files here. If I do create files, create underscore files now without the .sh, it should work too. It's not working, huh? Why is that? Let's go back to, did I not? Might have forgotten to modify the permissions. All right, let's move into the user/local/bin files. And this is like a step that I skipped here for trying to like save time, right? So have you ever like installed something on your developer machine and then they tell you like make sure to change the permissions, and then you just randomly type in, all right, chmod 755 or something like that? Well, what you're doing is changing the permissions on the file, right? And when you do ls-l, you can see the files that are here. For example, we've got no permission read write for the user, and then we've got execute read write for the group and things like that. Permissions and links and stuff like that. I'm probably going to do a different session on that because it's a little bit more involved, but that's essentially what you're changing to. So if I go into, let me list the stuff here. Looks like I have a kubectl in here too. So if I do chmod 755 and then create files, I need to do sudo again because I'm in chmod there, 755 to create ls. Cool. Now I should be able to do this. Create files, but just like that. Create, it's not working, huh? I'm pretty sure this worked before. Interesting. Let me do echo path here and see. We got user local bin is in here. User local bin, user local sbin is also in here, huh? Did I added the bin in there too? What is it then? Create files.sh. That worked there. For some reason, the extension works there. But we're getting permission denied because we didn't do it with sudo. And the reason we're getting continue to get permission denied is because it's in a bin directory. Bin is where binaries and things are installed. So for, I guess, safety, not I guess, for safety and security purposes, they require a password, right? But anyway, that is a very, very short introduction to the shell scripting. Essentially, you start your files with bin/bash, and then you type in your things, and then it'll run commands for you, right? Bash scripting has its cons, and then at an extent, you'll probably want to dive into something like Python or Perl or other languages because it does have its limitations, but it's great for putting together stuff that you would automate when you're like using a Linux machine, right? All right, I have to wrap up. We'll go here. I am going to answer some questions before I end, though. There was a bunch in here. Let me take a look here. Can't wait to share these recordings with my son. So glad I recorded. Yes, this will be available for everyone to watch. It saves to my channel like right away, and then it'll also be on the Reactor channel too. Let's take a look. I think we got all the questions here. Yes, we did. All right.
Sorry,
cool.
I dropped so many messages in the chat. I kind of drowned out the audience commentary.
No worries. We do have to like wrap up, but yes, this was Bash. I tried to like fit a whole bunch in there. There was a lot, and then I got an error at the last one. But the GitHub repo will have a lot more stuff for you to dive into, and then check over that Learn module. Next week, February 8th, we're doing an introduction to Terraform with my good friend Rishabh. Rishabh was a DevOps engineer up until last week. He recently started a new position at Google Cloud, so very congratulations to Rishabh. But he's joining us next week to talk about Terraform, which is something that he's been working with for a while now. Infrastructure as code is very important as well when it comes to cloud computing. So Terraform, next week. Spend an hour. Rishabh's going to be hanging out with us, teaching us a bunch of stuff too. All right. Rebecca, anything else?
Awesome. Thank you so much. So I dropped a bunch of stuff into the chat. If you all have time, do submit a survey. We use this information just to kind of know who our audience is so we can future develop content. So if you have a few minutes and just enter the event code for this session 15158. If you're not part of our network, do check us out. The Reactor's constantly putting out content. We have great people like Gwyn coming on all the time and putting some really wonderful stuff together. Again, right now our website is down. So if you want to find some of our sessions, we are on Meetup. We have 12 physical locations. So based on those locations, that's where we post like time zone related. So definitely, find your local time zone, check out that calendar. You can sign up to more than one of our groups, on opposite ends of the world. So you get different stuff coming out. Yeah.
There's something on there for everybody.
Yeah, a little bit of something for everybody. So yeah, and as Gwyn mentioned, this is part of a all month long Linux series. So next week and then the following weeks after that, we have one a week. So
yeah, remember we have Terraform, containers, container orchestration. That's what we have lined up for the rest of the month. And if you speak Spanish, I'm doing this exact same session in Spanish on Thursday. If that's like your first language and you'd rather, I don't know, watch it in Spanish, or maybe you want to learn Spanish, come hang out Thursday.
Yeah, learn Spanish and coding.
Yeah, it's same time, right? Same time on Thursday.
Yep, same time Thursdays.
All right, I think that's it. We got it.
Awesome. Wait, somebody just quickly asked which language is Bash closest to? I don't know if you
I wouldn't say it's closest to anything really, because it's like a scripting language, very different from like traditional programming languages like your Pythons, your C#, your C++, things like that. So yeah.
Okay. Cool.
All right, everyone.
Well, thank you all.
Thank you so much.
Take care. Have a good rest of your days, evenings, mornings, wherever you're tuning in from. Till the next one.